my part, uplink scheduling. As I mentioned before, my part is for uplink. So in scheduling there are two parts, downlink and uplink. And in the end of our presentation, actually I will clarify about what Xavier asked before, because I already checked in my PDF. Yes, the user in RRC there is no user plane, and I will show the picture, the original picture in the end. And you can compare with my previous picture because I made by myself. And now we are going to the RLC function. Before that, I will mention before that there is a layer in scheduling. The lower one is physical. I didn't put it here, and the after physical there is MAC, and then RLC and PDCP and RRC. So we just focus on the three parts. Okay, this is the first. The first part is RLC function. The function of the RLC is transferring of upper layer PDU, and there are several parts like what you can see in the slides. And the other function is error correction through HARQ. So in RLC, it's very difficult to mention. In RLC, we use ARQ, but in another part like in MAC, we use HARQ. So a little bit different. And then resegmentation of RLC PDU, I will explain later. And you can get this page from the specs. And this is the part of RLC modes for uplink logical channel. So this is RLC, and there are like What is I will mention later, and AM and UM. And you can see in my explanation, RLC has several modes. The first is transparency mode, and unacknowledgement mode, and unacknowledged mode. But in uplink, you just only find UM and AM. You will not find TM. So what is TM, AM, and UM? Wait. So for TM, the configuration is for the broadcast channel. So you will not find TM here, but you will find a broadcast channel in the downlink. Yeah, because this is parts for uplink. And then the other is you will not find TM, because in the TM in the uplink, no uplink resource allocation for the RLC. So you will not find TM, because TM need like a resource allocation if you want to transmit. And then result for the TM. And for the acknowledged mode, and the difference between the acknowledged and unacknowledged mode. Actually, the difference in acknowledgement and unacknowledgement is only in the transmission. In the retransmission. Because in unacknowledgement there is no retransmission. And then, as I mentioned before, in uplink share channel, yeah, there are two parts: traffic and control. So they will go to the RLC layer, like this one. DTCH will go to the DTCH and so forth. And MAC is the layer between logical channel and transport channel. And for the physical between physical and transport channel, we call it physical layer. And MAC is transport channel and is a layer between transport channel and logical channel, and RLC is a layer between logical channels and ready barriers. After logical channel means RLC, and after RLC PDCP, and after PDCP RRC. Wait.
virtual payload, I think it's like SRP, ERP, SRP 0 or SRP 1 or 2.
Okay.
Where did you get this figure?
I get this figure from, I think, helix.com maybe. Yeah. And the explanation is like this one.
After the video.
Okay, we can quickly check it. Thank you for the clarification, for the interruption and clarification. And then this is the difference between the RLC in LTE and HSPA. Okay. In the you can see in the third table in LTE there is no jippering at RLC layer, and in the HSPA there is a jippering, like supported for acknowledged mode and unacknowledged mode. And the transparency mode, like I mentioned before, is only in common signaling channel. Okay. And this is for PDCP. So after we explain about RLC, now we are going to the PDCP function. The first, transfer of data. There are two parts: control plane and user plane. And between RLC and higher user plane interface. And I will show it like a table maybe in the following slides about which part is physical and make and others. And then the second function is maintenance of PDCP sequence number and transfer of sequence number status for use upon handover. Handover have already mentioned by Gina. And ROHC, robust header compression, is used for avoiding or wasting resource allocation. So like in another part, like in another slide, I will mention that there is like a power headroom. This is used for avoid wasting in power, but here avoid wasting in a resource in air interface. And then now we are going to this part. So you can see here there are assume that you have a three personal computer or 3 PC. The first PC is for UE, and the second PC is for E0B, and the third PC is for MME. MME is for the database of your system, and E0B is like the connection between the UE and E0B. And in my first figure, I give like a circle here and then the connection. It means that this is for the S1 interface. And in the last of our presentation, I will show you about the tutorial video that I have already uploaded to the YouTube. So we are already done about how to make a tutorial for this part. So we use like a 3 PC. The first PC is used for the UE, and the second PC is used for the E0B, and the third used for EPC actually, not MME. And this is like a layer, and if you are going up, it means that you are going to the upper layer, and if you are going down, you will go to the lower layer. So physical is lower layer, make layer is like a layer between transport and physical, as I mentioned before, and RLC is the layer between transport and transport and the RLC also. And if you go up, it means that you will go to the transport layer. Like if it no see, you will see like a physical, data link, and network, and so forth. Well, and this is for the LTE PDCP layer view. Okay, you can see here there is, as I mentioned before, header compression. What is the use of header compression is to avoid a wasting resource. And then yes, in this part there is a ciphering and deciphering. Means that ciphering is like you give a code and it will make your code will abstract, so no one will no one will be able to access your code. The simple explanation is like that. And then yes, I mentioned before in AM and UM. What is the AM? AM is like an acknowledged mode, and UM is unacknowledged mode. And in unacknowledged mode, you can see there are two ways here. So it means that you will be able to retransmit your data. But in AM, acknowledged mode, you only in acknowledged mode, you can see here in one line has a 2 row, means that you can retransmit your data. But in this part, you have to shift, because you cannot retransmit directly in one of the things here. Okay, well, we are going to the next slide. And now is for RRC function, the upper layer one. The use of RRC is broadcast of system information related to non-access stratum, and then broadcast of system information to access stratum. So there are access stratum and non-access stratum. And the third is paging, and establishment, maintenance, and release of RRC connection between UE and EU TRAN. And security function, because you can see in the previous figure there is like ciphering and deciphering. So this is used for the security function. And mobility function, and QoS, quality of service management function, and UE measurement report, and NES, direct message. And there are two parts of RRC state. The first is RRC idle, and the second is RRC connected. For RRC idle, yes, the state indicates that there is not signaling radio barrier is established in this part. So transfer of broadcast or multicast only data to UE, and there is a UE and specific DRX or discontinuous request. Okay. I forget. And maybe configured by upper layers and UE controlled mobility. And for the connected, the state indicates that there is signaling radio barrier established in an executable RRC connection is established, and RRC connected state can be further characterized as below. Transfer unicast or data from or to UE, and transfer broadcast or multicast data to UE. So you can find a difference between the RRC connected and RRC idle. And the RRC idle only transfer or broadcast multicast data to UE, but you can see here transfer of unicast data to or from. It means that you can transfer from UE or to UE for the unicast data, and you can transfer also a broadcast or multicast to UE. At the lower layer, the UE may configure with a UE specific TRX and PTX. Okay. Network control mobility is like handover and a cell change order with network assistance. And my other part is PSR. What is PSR? What is the function of PSR? I will mention later. Okay. The first you need to know is about the scheduling in this part. So there are two parts of uplink data scheduling. The first is persistence, and the second is non-persistence. I get these pictures from shared tech note. So what is the difference between the persistent and non-persistence? First, you can see here DCI format 1 and DCI format 0. This is the part of persistent, means that inode will always send a DCI format 0 to the UE. So even though UE didn't transmit anything to the inode B, UE will know which resource allocation is available to use. But if the non-persistent part, if UE want to connect to the inode B, UE need to request a scheduling first. So you can see here there is a worsening resource allocation in the persistent, because even though UE didn't want to transmit anything to the inode B always transmit about the DCI. Yes, like this one. And the DCI is like an element of the control. So means why there is a PDCCH, because DCI is a control. Like DCI is not the data. DCI is a control for the signaling. So that's why you use PDCCH. PDCCH is physical downlink control channel, because DCI is a control. Yes, and if you want to ask inode B to give you resource allocation in the non-persistent part, you will send a scheduling request through PUCCH. PUCCH means that physical uplink control channel. So scheduling request is kind of the DCI. This is the control element. And then after inode B get the scheduling request from the UE, inode B directly answer, and the answer is DCI format 0. DCI format 0 contains an information which resource allocation is available to use by UE. And after UE know which resource allocation is available, UE will directly upload the data. Means that uplink data. So because UE use a data, so UE will use a shared channel. Yes. And then after inode B get UE data, inode B will send it egg and egg using PHICH. What is PHICH? PHICH is physical HARQ indicator channel. So this is for the HARQ. And actually the concept is same, but the difference between the persistent and non-persistent is a little bit different. So you can see the difference one between the persistent and non-persistent process is only in the first step. So the first step, like this one. Okay, continue to the next slide. So what is the function of buffer status report? BSR is a kind make control element which carrying an information on how much data in UE buffer from UE to network. So buffer status report, like you will get an allocate resource uplink when you want to transmit. So this is like if you want to transmit to, assume that you and your friends A and B, you are A and your friend is B. You want to transmit to your friend B, so you need to ask first to your friend, is there any available data or resource allocation can be transmitted? And your friend, if your friends say yes, and you can transmit like that. The simple concept is like that. And the function is allocate UL uplink resources only when a particular UE has something to transmit, as I mentioned before, A and B. So you will not know about the resource allocation available in the B part if you didn't ask your friends, like that. And this is very useful to avoid allocating resource allocated, because the resource will available only if you ask your friends. Yes, like that. So the resource allocation will available if your UE ask inode B to give a resource allocation. And this is the classification of BSR. There are two big parts. The first part is a data structure. So BSR can be classified by data structure. The first is for short BSR, and the second is long BSR. If it is classified by data structure. If the BSR is classified by a timing, there is three parts: regular, periodic, and padding. And the process is like this one. So this is process for non-persistent, because there is a scheduling request here. So if you need to transmit anything to the inode B, you will ask first using a scheduling request, and it directly send a buffer status report. And yes, and if grant allocation is not sufficient, you need to retransmit again. And according to the data structure, paper size can be classified into the short and long BSR. But the maximum is always 6, which means that it presents only 0 to 63. So there is 64 parts. Like you can see here, 1, 2, 3, 4, 5, 6. So this is the maximum. Means that 0 to 63. And if you use, there are 8 slots here, but we only use the maximum one, 6, because only for 0 to 63. So if we use a maximum one, I mean here, we only use one BSR, so we will get a logical channel group ID. But if we use a long BSR, you will not see logical channel ID here. Like this one. Okay, I will mention. Buffer size, the maximum is 6, right? And after that, you will give a buffer size, another buffer size. So remaining is only 2, 1, 2, and for the remaining, you can see here, 1, 2, 3, 4. So the maximum is always 6. Like this one, 1, 2, 3, 1, 2, 3, 4, and 1, 2, 1, 2. So 6, always 6. And then, okay, I will not mention this word because it's too small. This is like a combination of buffer size. So this is need to get a maximum number. If you see like in the 0 index, this is index. Yeah. This is for index, and you can see the maximum number here. It is better if you use this number. So if your index is 9, it is better if you use the maximum number 1. Because the more size you have, the more resource allocation you will get. Okay. And for the regular BSR, this is the part of the classified. If you classify the BSR for the timing part. So BSR will be sent by UE if UE has some data to transmit in RLC or PDCP entity for a certain logical channel group. And the second is new data arrives in uplink buffer and already existing data. And the third, new data has a higher priority than those which wait in uplink buffer. This is the kind of the part if the BSR will be sent in the UE. It will be sent by UE. And the fourth, retransmit a BSR timer expires. And if there are uplink resource for new transmission, transmitted on the resource allocation. If no, it will trigger scheduling requests. So this is the for regular BSR. And for the periodic BSR, the timer control periodic reporting. This is part of periodic, and trigger if periodic BSR time expires, and transmit on uplink resource allocated for new transmission. This is the use of BSR if you classified by periodic BSR. And for the padding, there is like a space. Padding is like a space. So you will transmit instead of padding on uplink resource allocated for new transmission if there are enough padding bits. And I will show in the following when we need to transmit a long PSR on or short PSR. Okay, like this code. This is for the periodic and regular PSR is in the left part, and for the padding is in the right part. So this is when we need to transmit a long and short PSR. If the number of logical channel group with allocated data is more than 1, means that long PSR. But if the logical channel group allocated less than 1, so it means that short PSR. So you can see here, if the logical channel group is more than 1, like this one, more than 1 people, so it means that this is for the long PSR. But if less than 1, so you can see a logical channel group here, means that you transmit a short PSR. And for the padding, this is for the periodic and regular PSR. And for the padding, actually the concept is totally same, because you can see here, if the number of logical channel group more than 1, you will transmit a long, otherwise you will transmit a short PSR. So the other part is HARQ and ARQ. ARQ is automatic repeat request, and HARQ is like a hybrid automatic repeat request. The difference between the HARQ and HARQ, assume that you have HARQ, so you will know that H is the adding part to ARQ. So if HARQ means there is a difference between the ARQ, I mean there is an addition part in ARQ. So the concept is simple. Is simple, I think. Not as simple. It's a little bit different. Little bit difficult. So in the left part there is a ARQ, and in the right part you can see HARQ. Okay, I will explain. So assume that P1 is a picture, and if you transmit a picture to the receiver, and your picture is in trouble here, so the receiver will retransmit. The receiver will transmit a neck. Neck means non-acknowledgement to the transmitter. So after that, transmit get, oh, my picture I already sent to the receiver is in trouble, so I need to retransmit again. So in TX will retransmit again of the picture 1. So the process is like this one. This is for the ARQ. And for the HARQ, actually it's same. Yeah, like this one. If you transmit a picture 1, okay, in this part there are picture 1A, and the other part is picture 1B. Means that if you transmit okay, like this one, this is a picture, this is a big picture. I will separate it in the center like this one. So the left side and the second and the right side. If I transmit the left side and it is in trouble in the transmitting, so I will transmit again in the first part. But in HARQ, it will combine. It will a combination about the first transmission and the second transmission. So if the first transmission you have broken in the left part, it will keep the right part, the correct one, and ask to the transmit to send again pictures. And if the second picture will be sent by transmitter have a trouble in the other parts, so it will combine like this one, B and A. So after they get a combination of the A and B, they will get the receiver will get the good picture. Okay, a little bit difficult if you see about this figure, but if you see the following slides, you will understand what is the meaning of HARQ, like this part. Okay, I have a picture like this one. I have a picture like this one, and I transmit the picture, the first picture, and I get the I get the incorrect picture, like a blur picture in the other parts, and the first transmission has a difference blur, and in HARQ it will combine, so we'll get the final picture. So the picture is like this one. In uplink, there is HARQ and synchronous protocol, of course, and the function is to retransmit occurs at a predefined time after the initial transmission, and the second is the process number can be implicitly derived. And non-adaptive protocol, this is the typical way. So retransmits must occur at the same frequency resources. So and with the same transmission format as the initial transmission. So for the non-adaptive, it will use the same resource allocation. For the adaptive, it will use a different resource allocation. So it will avoid collision in the non-adaptive. Sorry, in the adaptive part. Yes. Yes, this is the difference between the adaptive and the non-adaptive. You can see here, non-adaptive, no DCI, means that if you get this no DCI, it will use the same resource allocation. So if you use non-adaptive HARQ, you will get a collision, because if you use the resource allocation, if you use the same resource allocation and another one when you transmit again and use another same resource allocation, so it will collide. But in the adaptive HARQ, you will get a DCI. DCI, where is DCI? Yes, you will get a DCI. Yeah, this one. UE will get the DCI from the inode B, so UE will understand which part can be transmitted, which part of resource allocation is available. So UE will transmit it at that part. Means that in the updated HARQ will use the different resource allocation, but for the non-adaptive will use the same resource allocation. So in non-adaptive you will always collide, not always, but you will almost and sometimes collide with others. And this concept is like this one. This is for the non-adaptive. You can see only use one resource allocation. As I mentioned before, in non-adaptive only there is no DCI, so you will only use one or same resource allocation, like this one. But in adaptive retransmission, you will have another slot, so you can use this part, you can use this part, and you can use this part. This adaptive retransmission is used to avoid a collision. And this is for the HARQ timing. Timing relation between downlink data in subframe and uplink HARQ, subframe N, and uplink HARQ acknowledgement in subframe N plus 4 for FDD. So this is like a frequency, and you can see in the figure below. There are parts like N is the first you transmit your data, and you will wait until N plus 8, because N plus 8 is HARQ round trip time here. So after this part, you will start to transmit your data. Why we need this one? This will avoid a UE to transmit a wasting in air interface.